Welcome to Chill Skills Sporlan Tech Talks. The topic for this episode is supermarket methods of temperature control, electric evaporator pressure regulators, otherwise known as EEPRs. If I count correctly, this is about the 12th one of these in a series of presentations that we've been doing that's following the agenda of the old supermarket seminars. You know, John, pretty soon I'm just going to stop counting these.
I would if I were you.
Yeah. In the past, Sporlan had a team of professionals on a supermarket team that went around the country to do these in person. With this Tech Talk entry, we're bringing that same supermarket seminar concept back, hopefully getting to a larger audience and helping more people in the process. And you know, if we were still doing the in-person specialist classes and supermarket seminars, in order to maintain that 6-foot clearance between everybody, we need a really big, large room.
Very large.
Yeah. Here's a shameless promotion for the next webinar we're going to do. In early October, we'll be presenting part 2 of the What is Refrigeration presentation. This webinar would be perfect for anyone who wants a better understanding of the vapor compression refrigeration cycle, or for someone simply wanting a review of the basic concepts. You know, if you watched part 1, you really ought to catch part 2. We really bring it all together and do it in kind of a fun and easy to understand way. What did I say before? Even an accountant would understand it.
Even an accountant.
Maybe even a general manager.
Yeah, who knows?
Catch us on October the 1st with that one. Here are a few simple instructions. If the speaker on your computer doesn't work, you could simply dial in with your phone. There should be a phone number somewhere on the invitation that you originally received for the webinar. But here it is on the slide, just in case you don't have it handy. I think that's it right up in here. As we move along and you have questions, you could always type those into the Q&A window. We'll answer some questions live as we have time, but if we run out of time, we'll eventually post answers online. However, if you hang on, there's a good bet that we've anticipated a question you might ask, and we've included some discourse in the webinar itself that would address it. And just so you know, this thing's being recorded. You can always go back and listen to it on Facebook Live. It'll appear there first. And later on, we'll post it on the Sporlan YouTube channel. Hello, I'm Jim Jansen, Senior Application Engineer for the Sporlan Application Team. That's the handsome guy here on the left. Joining me today again is John Whithouse as my co-host. John is a Senior Principal Engineer for the Sporlan Division. He's a published author, consultant, and as I've said in the past, all-around extra smart guy. All that means John's a pretty big deal around here, and I'm really excited to have him join me again today. John, please say hi to everybody.
Good afternoon, everyone.
I thought you were going to say hi, everybody.
Oh, I can say that too. Okay. Hi, everybody.
And Phyllis, our communications director, she's also in the room with us today. She tells us what to do and when to do it. Every once in a while, we'll actually listen to her. If you have any follow-up questions or feedback, you may contact us via email or contact the Sporlan Technical Support Team at svdtechsupport@parker.com. You can always call 636-239-1111. I think that number still works. That's our general
I believe it does.
Access number to our headquarters in Washington, Missouri. And you actually eventually could talk to humans. You can see our own personal email addresses are underneath our names. You're welcome to contact us there as well. Here is a representation of the basic vapor compression refrigeration cycle. And as you can see, we've circled the 4 primary components that exist in every cycle of this nature. There's the compressor here. It compresses low pressure and temperature vapor to a high pressure temperature vapor. The condenser does its job by rejecting heat to the ambient, and that ambient might consist of air, which is often the case, or it might be water or some other medium. The refrigerant vapor there will condense to a liquid, and this will all take place at a constant pressure if there's no glide inherent to the refrigerant. And we'll talk about glide in a future webinar because I think there's enough question about what that really is and what it means that we ought to address that. What do you think, John?
Definitely. A lot of misunderstanding and just maybe even some bad information out there around glide, and it's something we should address.
We'll fix that. Here we have a metering device depicted. In this particular instance, there's a thermostatic expansion valve holding this place. It's generally equipped with a small orifice, and there will be a high pressure drop across this device that works in concert with the high pressure increase produced by the compressor. The refrigerant changes from 100% liquid to a saturated liquid and vapor with that associated drop in pressure at a relatively constant enthalpy. Boy, that's a $10 word. You want to learn more about enthalpy? You join us on October 1st. Here's the evaporator. Refrigerant absorbs heat from the refrigerated space, and the refrigerant boils and changes phase. It should be 100% vapor as it leaves the outlet so that we don't cause problem at the inlet of the compressor, and everything continues on and over again.
Correct.
Here's an application of that basic refrigeration cycle in the form of a DX multiplex rack. And indeed, it looks quite complicated and daunting. But just remember, there's still those 4 primary components in every system. Everything else that's added on just helps things to work as the seasons change and the load does the same. We'll be discussing some specific components within this highlighted region. We've talked about methods of temperature control that include solenoid valves and thermostats, mechanical EPRs, and today we're going to cover electric evaporator pressure regulators, or in other words, the EEPR. In comparison to the EPR, this option requires a controller to accept the discharge air temperature reading from a sensor. The controller then positions the EEPR. By stepping the EEPR in a closing direction, the pressure will increase and cause the discharge air temperature to also increase. For the sake of clarity and ambiguity in this particular example, all in one fell swoop, we've elected to eliminate the cap, tube, and bulb in the external equalizer from the thermostatic expansion valve. I guess, what do you think? Those Sparky guys intentionally sabotaged the TV, John?
That's my guess, yeah.
I bet. And we didn't even show the distributor that would be required over here to get this multi-circuited evaporator to work. But what we have shown is the temperature controller and that sensor and the electric valve that's needed. Regarding controllers, Sporlan offers a standalone controller to drive the EEPR. Here are some examples. Temperature control, for instance, and the associated pressure control. These are all variations of this temperature device here that we're showing, which is part of the Kelvin series of controllers. Also, some case controls can operate as standalone controllers as well. More commonly, EEPRs are controlled by dedicated boards or case controls that communicate with the store's energy management system or the building automation system. This allows the technician to see and monitor case temperature, valve position, and a whole host of other things. This can take place from the controller or even from a remote location. And that's right, I said remote control.
Remote.
Pretty neat. We've already talked about standalone controllers, but here's an example of another kind. This one can readily interface with the building EMS and can control many additional parameters. These electric valve controllers are classified as integrated controls or case controllers. Here's an example of Sporlan's S3C control. John, what is S3C? That's kind of a fancy name. What does that mean?
S3, 3 S's, safety, service, and security.
Oh, that's kind of cute. We offer a complete online training module for this control that you can go on, take a little test, get certified.
Indeed.
Pretty neat. This case control drives, if you like, an EEV, or in addition to the EEPR, maybe even a liquid line solenoid valve. And it also has onboard relays that you could use to control lights, defrost cycle, fans, and anti-sweat heaters. You could even control an SPD, listen to me, an SPW valve as well. And all these acronyms. John, what's SPW?
The S, I'm thinking, stands for Sporlan. PW stands for pulse width. That is a pulse width modulated expansion valve.
A really fancy version of that. We'll talk about that in a subsequent webinar as well. These case controllers are typically in communication with the energy management system for data storage. And there are case controllers provided by a number of different manufacturers, not just us, Microthermal Technologies and even Novar. With any of these controllers, choosing the right sensor or sensors is really paramount. Sporlan offers multiple temperature sensor options, ranging from the 2K, 3K, and even 10K thermistors, and I think there's even some more in the lineup. The Sporlan surface sensors can be identified by their brass housings. Here's an example of that right here. The 10K sensor, which we're showing over here in this area, is used predominantly on that S3C case control. John, just real briefly, this 2K, 3K, 10K, what does that mean?
That has to do with the resistance, the base resistance of these thermistors. And typically, the higher resistance thermistors tend to create the more accurate sensing for the controller.
For the application.
For the application.
Gotcha. And then I guess as the temperature that's imposed on that sensor varies, the resistance varies as well. Is that how that works?
That's correct.
Pretty cool.
That's why they're called a thermistor.
That's what, Mr. Thermistor. When needed, the appropriate pressure transducer should also be selected, and it would be based on the pressure range seen in the system. For instance, 0 to 150 psi, 0 to 300, or even 0 to 500. These newer models can be identified by the color-coded labels and the stainless steel construction that you see here. Pressure transducers would normally be used for superheat control or even pressure control. Here's a wide range of Sporlan products depicted on this slide. Some are even a little dated in their design features, and we've included them here as a good illustration nonetheless, because when you're out in the field, you're not always just going to run into the newest and greatest. You're going to see older products that are installed that we're hoping will work for many years. These electrically actuated, electronically controlled valves can be used to not only control evaporator pressure, but also superheat, hot gas bypass, glycol flow in a secondary application, and even head pressure. There are also specific standalone Kelvin 2 series controllers available to help the package in most cases. These valves have the advantage of being less sensitive to the refrigerant installed in the system and can generally throttle down to lower levels as compared to the mechanical EPR. John, how much lower can they throttle based on their nominal performance ratings, do you think? What would be a good answer? I'm surprised somebody hasn't asked that question.
You can typically take one of the electric EPR valves, one of the pressure regulating valves. They'll control well down to maybe as low as 10% or so.
Oh wow!
Of their rated maximum rated flow. And for the expansion valves, they can readily control down to about 20% of their maximum rated flow.
And then as another thing, again, we mentioned this earlier, these can be monitored and controlled remotely if the right accessories are in place on the job.
Indeed.
And that's something that a mechanical EPR is going to be hard pressed to be able to do.
Yep. Not so capable with a mechanical device.
We offer a wide variety of CDS valve sizes as well. And again, we've depicted some dated designs again for reference. The larger sizes, the CDS 9 and 17, can easily be identified by the brass motor housing. And as owner operators and OEMs all decide it might be a good idea to install doors on the refrigerators, reducing refrigeration circuit loads in the process, the need for smaller CDS sizes has resulted. And that's why you see the CDS 2, 4, and 7. They can be identified by either a stainless steel motor housing and and a removable cable assembly like you see over here. This has the old clamshell style. This version has the newer M12 cable assembly.
Mm-hmm.
Now, most all these cables assemblies are removable. They're just not all reattachable. If you remove the cable assembly from this version, you'll do it once. And then you'll get to come back to us to either buy a new valve or some extra parts to make it work.
Correct.
Because this cable assembly doesn't go back on.
That's correct.
Now here's an example of the CDS 7. We'll see the internal parts and piston movement. The animation will also show the removable cable and motor assembly in this example. Now, replacement motors are available for this product, and you can find all the parts for these valves in our Bulletin 122, which you can find on the Sporlan.com website under literature. Replacement motors are shipped with the piston at mid-stroke. You'll see this motor assembly come off and separate. If power is applied to the motor prior to reassembly, be sure that piston has been retracted before installation. And we've got a neat little tool that we can provide to you that will help you with that we'll show you shortly. By retracting that motor assembly, it'll help avoid any damage to the internal parts. For example, a fully extended piston could likely bind and perhaps actually be damaged upon reassembly if you're not careful. If you're doing a CDS installation, whether it's new or replacement, be sure to program the valve resistance and program the number of steps and the step rate into the EMS or the standalone controller. You know, we show the valve resistance right here. Some of them are set up as 100 ohms, plus or minus 10% at an ambient condition of 75 degrees. Others have 75 ohm motors. I was going to say something smart like check the ohmage, but I don't think ohmage is a word.
I don't think
I
it
think
is
George
either.
Ohm's got the short end of the stick on there because, you know, you talk about volts and voltage amps and amperage.
He did.
That's
He was shorted, definitely.
Sporlan valves are typically designed with a 200 step per second step rate. And then, of course, the resistance varies based on the number of steps in any given valve design.
You know, this is a pretty good time to point out, we look at the number of steps there, particularly on those larger models, 6,386 steps.
Yeah.
You know, that
That's a
number of
bunch.
steps, you know, facilitates some very fine control of those valves. So that's just one of the things you can look at that tells you that these valves are capable of some very precise control. And we have a couple of charts that's going to show you just how precise that control
Yeah,
can
we're
be
getting there. You bet.
on a system.
You
I mean,
bet. You bet. Troubleshooting EEPRs. Controllers will typically allow the technician to see important control parameters and readings. When integrated with the EMS, that's that energy management system, these readings can be graphed and viewed as time varies. The EMS would also show any alarm warnings if set points are not being met. And again, these systems are intended to be monitored remotely. You can't do that with a mechanical EPR. Let's now take a look at this next slide. If you're troubleshooting with like the microthermal system, the technician or the facilities manager can actually zoom into an area like what we've shown here of the store to investigate any alarms and review case parameters and system data. And here in this case, it looks like there's a red icon indicating an alarm scenario. Maybe the case is below set point or not meeting set point in some type, in some way. Troubleshooting in general, as far as access to the case and circuit information, we've got a host of information ranging from liquid subcooling, evaporator superheat, discharge air temperature, valve position, liquid pressure, suction pressure, motor winding resistance. All of those things would be accessible with the correct setup. Now, here's that tool I said would be handy anytime you're using any of our electrically actuated, electronically controlled valves. This step motor actuator 12 volt is a necessary tool that you can use to actuate the valve when it's not hooked up to a controller. And it's just a viable tool that you really need. Also on the M12 pin, it'd be a good thing to inspect it for integrity and that you haven't bent any pins. And one thing I haven't shown on here is simply an ohm meter.
Correct.
Checking resistance, checking voltage, all that sort of thing.
Yep.
That would be an invaluable tool for you to have as well.
To be able to know we have the correct resistance across the windings, lets you confirm that you have a properly functioning motor.
Right. Now, as time goes on, facilities are required to undergo refrigerant retrofits, legislation, a whole number of things are driving that. And I'm sure you don't want to go through every system component in a retrofit. We put together this reference chart to provide some general guidelines and things to consider with retrofits to 407A, 407F, 448A, and other similar refrigerants. Shoot, it's even color-coded, which I guess if you're like Heath, you're thwarted with color blindness, so it might not be too much use to him.
Yeah, it could be.
As you can see, there's quite a bit of green up here, or probably okay. Some yellow indicating caution. You need to maybe examine it a little further. When we look at electric EPRs, you can see that there's a lot of likely okay or maybe good practice to check it out. But the thing is, they're much more forgiving to a refrigerant retrofit than mechanical valves are going to be.
Correct.
Right.
Because of that wider operating range, typically not run into a situation where you would have to change out an electric valve in that situation. You can typically do those retrofits, and you certainly may need to give consideration to your expansion devices.
Yeah.
But things like the electric EPRs are typically going to be just fine as they are.
Now you notice we've got some yellow and red down here. When it comes to filters, oil, external seals, red means probably not okay.
Yep.
It's important that the system be leak tight, clean, dry, and that's a benefit to everybody.
It'll make for a much more reliable system, better performing system, and a more energy efficient system.
Oh gosh, John, this animation's already started. A lot of folks will ask us, we have an older EPR, but we're doing a renovation project and would like to include some of these fancy electric valves. Boy, that motor assembly dropped out of there real quick. And they said, do we have any other options besides changing the whole valve? Well, as you can see here, just take a look. We've got a parts kit that'll let you convert a SORIT valve to a CDS valve. Mm-hmm. And as you'll notice there, those pilot lines were blocked off and plugged in order to seal them. We do that when we're in the lab for sake of sealing that. Out in the field, you could clip those flare nuts off and braze them closed, but we like to have access to it so we can change things around when we're doing tests. But the body sleeve is removed and a number of other different parts are changed out, and then you wire the valve to a controller and you run the sensors that are needed, and of course don't forget that you've got the need to maybe consider some contamination protection, but installation of this is pretty straightforward.
It's very straightforward.
Yeah.
If you wish, as we just demonstrated here, this conversion can be done without ever firing up a torch.
That's true. But there's one thing that you do need to do, and that's isolate that valve from system pressure before you begin this process.
Correct.
Or you're going to have a little more than a de minimis leak.
Yes, that would be a significant leak. I think that would be considered. Yeah.
Discharge air temperatures are typically monitored by that EMS that we've mentioned multiple times now, and they may even be equipped with the logic to control the EEPRs. That would mean a complete EMS upgrade likely not be required for you to do a retrofit like this.
True.
Neat thing is we've got these for a wide array of valves. The refrigerating specialties Sport to CDS kit is also available to retrofit that sport valve to a CDS design. Again, we're planning a whole series of webinars that will cover the refrigerating specialties products in the near future.
I think that helps to illustrate just how universal and effective this method of pressure regulation can be when you can retrofit these older valves and actually get a better performing, more monitorable, for lack of a better term,
Right.
valve out of it. That really, I think, goes to illustrate just how versatile and effective
Pretty awesome.
this method can be.
Here you can see the SORIT and Sport the CDS retrofits. Supermarkets can realize some pretty decent energy savings. I've been told up to as much as 10% or more. Now, how well does it work? Well, here's a log of data that was acquired on a system with an electric evaporator pressure regulator. It was a medium temp system. This graph displays case temperature in degrees Fahrenheit, discharge air temperature versus time. The set point was approximately 37 degrees. And as you can see, the temperature varies approximately plus or minus a half a degree. Is that right? A half a degree?
That's pretty impressive.
Yeah.
That's the results that were measured.
And it tracks fairly closely to the set point. It even recovers fairly quickly from this defrost cycle. Mm-hmm. This is a very efficient way to control temperature. Now, let's compare the performance of this method with a couple of the other methods we've discussed in previous webinars. Here's the mechanical EPR control. It's pretty darn good itself.
Still pretty good, plus minus about 1 degree F, but not quite as quick a recovery, not quite as good a recovery coming off a defrost, though. No. Well, if you notice that.
That's exactly right. And it does vary, like the plus or minus 1. So not quite as good, even though this is a very effective and efficient way to control temperature. Now, let's compare it with the first method we discussed in a few webinars ago, and that was when we took a liquid line solenoid valve and cycled it with a thermostat.
That's just kind of ugly in a way.
Well, that's such a harsh way to look at this, John.
Okay.
If you're satisfied with this level of accuracy, this design may be perfectly acceptable for your application. It's an interesting comparison.
That's true.
It boils down, you pays your money, and you takes your pick.
The engineer in me likes those nice, smooth, flat lines, but it really does depend on your individual needs and your budget as well.
Absolutely. Now, if you haven't posed any questions to us, and I don't know if we've been getting hammered with questions or not, you can type your pertinent questions into the Q&A window. I'd say save your impertinent questions for later, and I'll let John answer those. Again, this is being recorded so that you can go back and listen to it for your pleasure and education. Do we have any questions, John?
At this point, our questions have been kind of few and far between. Couple I've been able to answer here as we've been going through this.
Perfect. Well, that being the case, we're just about to wrap this up. As a reminder, Sporlan is always here to assist you with your air conditioning and refrigeration flow control needs. You can reach us by calling the general number for Sporlan headquarters. That's 636-239-1111. You can get tech support with this number, 636-32, I can't even talk anymore, John, 392, I was going to say 329, 392-3906, and humans that are located here in Washington, Missouri will actually talk with you to help you solve problems.
Humans that have a lot of refrigeration and air conditioning experience
and
background.
Absolutely. Email svdtechsupport@parker.com. And we're always here 24/7 to help you at sporlan.com, where you can access product literature. You can download that. You can sign up for our e-newsletter. You can look at Virtual Engineer. That's our online sizing and selection tool. You can always stay connected with us.
Mm-hmm. We'd really encourage you, if you have interest in some of our products, to check out Virtual Engineer. It is a thoroughly modern, new generation selection software.
That have nothing to do with the fact that you manage that project, right?
No,
nothing
whatsoever.
Yeah.
Nothing whatsoever. Yeah. You did mention something about a shameless plug before. Well, this was my
shameless plug. Yeah, I got you.
Yeah, this is mine. So, but it is a completely web-based program. Requires you to download nothing whatsoever.
I don't know how to do that anyway.
And you can run it. Anything that you can run a web browser on, you can access Virtual Engineer on. So
awesome.
Anything from a PC down to your phone.
Hey, I'm being prompted to tell everybody that we are recording this. It'll be on Facebook first. We do a little editing and then we put it out on our YouTube channel. I just want to remind you that there's another webinar coming up on October the 1st. That's going to be here pretty quick. John, I better start putting the slides together for this. And
That's
it
right.
will wrap up part 2 of what is refrigeration. And again, I encourage you to join us for that. And with that, this concludes our webinar on methods of temperature control, electric evaporator pressure regulators. Thank you for completing another Sporlan Chill Skills Tech Talk. Join us next time.